everything for the day. And then also we help do hurricane forecasting. So when a storm's approaching, we'll start releasing balloons every 6 hours for the Hurricane Center so that they can use that in their rapid update models to figure out where the storm is going. So this is a 1,000-gram latex balloon. It's attached to a parachute, and then we have a radiosonde that's attached to it. It has a temperature sensor, a humidity sensor, and a downlink. And so this radiosonde is tracked by GPS. So as it goes up, it sends a signal back, and differential GPS calculates the difference between where the radiosonde is and where it was released to give us wind speed and wind direction. We get that data every second, and then we look at every 100 feet of that data. So we have meteorologists on staff who will quality control that data and send it out to the launch customers, the weather squadron, and then the weather community. So the weather squadron uses this data every day to do forecasting for any activities that are going on the range. And the launch customer uses the data for their day of launch upper level winds forecasting. So since this data gives us 100-foot wind speed and wind direction, our meteorologists quality control that data, send it off to the launch customers, and they use that for their trajectory design of their vehicle and their inertial loads testing. So when a vehicle is going up, it goes through its maximum dynamic pressure region, and that's where it's most susceptible to shears. And so the launch customer can take the wind speed and wind direction data and look at the wind speed and wind direction change with height to determine if there's any shear that could cause the vehicle to be catastrophic. So we start releasing these balloons at L-4 hours. We release continuously about every 20 minutes through T0. And then if there's a window, we will continue on a regular basis through the window. I think that's about it. Does anyone have any questions about this balloon?
What is -4?
-4 hours. 4 hours prior to T0, we will begin releasing weather balloons.
What is T0?
T0?
Yes.
Liftoff.
Gotcha.
So this balloon provides the thermodynamic data. We also have this balloon over here that provides just wind speed and wind direction data. It gives us a higher resolution. So some launch customers utilize this balloon for their wind speed and wind direction data as opposed to this. It's just customer preference, and it depends on the vehicle, the payload, and then their maximum altitude. So this balloon goes to only 55,000 feet, while this balloon goes to about 115,000 feet. They travel 1,000 feet a minute, both of them. So this one takes about 2 hours to reach its max altitude, and this one only takes about 60 minutes. Yes.
Yes, Mark Dotch, historicalaerospacenews.com. Can you tell me, in looking at this weather balloon, thinking of a rocket launch, and looking forward to the edge of Earth's atmosphere leading to space, this balloon, in terms of that weather, the upper level winds, etc., how will this balloon, will it record right till the edge of space?
It will record as high as it goes. So since this one goes to about 115,000 feet, we will get data every second up to 115,000 feet. The maximum dynamic pressure regions that the launch customers are usually concerned about is somewhere between 15,000 feet and 40,000 feet. So the upper data is usually used for climatological reasons for the weather community.
Thank you.
Mm-hmm.
Can you kind of describe the balloons a little bit and why they look so different?
Okay, so this one, since it's a latex, it's very smooth on the outside, and it creates a laminar flow around the balloon. And unfortunately, that makes the radiosonde a little unstable. So because it's 70 feet below, it swings like a pendulum. Well, that swing has to be filtered out. So this data we call our low resolution. This balloon over here has all these little nodes that protrude off of it, and it stabilizes the balloon. So it acts like a golf ball. And then since that balloon doesn't get temperature or humidity, we can put a radiosonde directly underneath it. And then since it doesn't swing like a pendulum, that data doesn't have to be as filtered. So that's our higher resolution. So some customers prefer to use that. Some who need thermodynamic data want to use this.
So I just talked to our station in Orlando, and they said currently it's cloudy and gloomy over there right now.
Oh, okay.
Is that going to affect the operation here?
No. The only thing that will impact releases are phase 2 lightning. So if we get lightning within 5 nautical miles of the facility, we will not release due to the safety of our personnel. But usually in an atmosphere like that, you don't want to release a balloon anyway. So in a phase 2, we're probably in a thunderstorm. Okay, so it's raining. We release the balloon goes up, it gets wet, right? It goes through the 0 degree line, and then it ends up freezing. So when the balloon gets covered in ice, it can either sink, float, or burst. And that data is unusable. We can't, that's not going to get us our required upper level winds data for the customer. So we try and actually avoid releasing in those environments. We are one of the only instrumentation systems on the range that speaks directly with the customer. So we have a set schedule ahead of time of when we're releasing in the count. If a storm's approaching, we will call them and say, a storm's coming in 30 minutes. Can we throw up these balloons early? Let's delay this one. We work really closely with the weather squadron and the launch weather officer specifically to get the forecast of when we are going to go into phase 2 or when we're going to get storms overhead. We want to get the customer the most data, and releasing into that type of environment isn't conducive for anyone.
Is the data real time, or do you have to?
Real time. Every second.
So it's two different balloons, but is it the same type of radio sound on both?
Yes, this one just doesn't have a temperature and humidity sensor. This one does.
Okay. And then
exactly the same except for that.
Just curious, as a former National Weather Service intern who has launched a few of these, so most National Weather Service offices, I feel like, launch radio sondes. How did this become the designated site instead of Melbourne?
Oh, I have no idea.
Okay, just curious. Yeah.
I can only assume, so we've been doing it out here since the 50s.
Yeah, I assume it's a matter of convenience, if nothing else.
Probably.
Okay.
And then the great thing about doing it on the base is so like the National Weather Service can only release at 11:15 and 23:15.
Yeah.
So if the weather squadron sees a storm coming in this afternoon, they can call us up and we can release the balloon ahead of time, and that way they can see how unstable or stable the atmosphere is.
Okay.
Because, as you know, as a weather person, your 6 a.m. balloon is not telling you the instability.
Yeah, we know when you get the 0Z and the 12Z launch data, certainly.
Yes,
okay.
Exactly. So the weather squadron has the ability to call us up 24/7 to release a balloon in support of any operation that's going on.
Controlled airspace.
What?
Controlled airspace.
Oh, yes. Yes. We do have to call and get clearance from the ATC to release, too.
I do that in Albany.
Mark Dodge, historical aerospacenews.com. Couldn't you tell me, this balloon, as it rises, as it heads to the outer edges of Earth's atmosphere, heading to space, it also records temperature. Can you tell me, the upper level atmosphere, is it much colder than that on Earth? And can you tell me what kind of variations there would be? Does the balloon actually shrink? And will it affect how it rises when it shrinks?
So actually, the balloon expands. It doesn't shrink as it
thank
goes
you.
up. So it expands. It probably gets about as wide as this high bay when it reaches the 115,000 feet. But the temperature in the lower portion of the atmosphere, the troposphere, that's where all the weather occurs. As you go up in altitude, your temperature decreases with height. So it's you're always going to go through the 0 degree line, and that's usually what determines whether you have snow or rain. So obviously, we have a very high 0 degree. We're in the northern latitudes; they have a lower. But usually about, 200 millibars, you're at minus 40 degrees C. So it really has no impact on the balloons. They just travel through it,
Wow, thank you.
as long as it's not wet.
We got time for one more.
You mentioned that there's a parachute on here. Is that for recovering purposes?
It is not. It's just to slow it down as it's coming down. So you just don't want it to speed down at 9.8 meters per second squared. So yeah, it'll slow it down a little. They've been recovered, but they're really unusable. They're a one-time use product. Anything else?
Can I ask really quick the cost of one of these balloons?
I cannot tell you this.
Can I just disclose it?
Yes.
And when you're talking about your customers, you're talking about SpaceX and ULA, right?
SpaceX, ULA, Boeing, NASA, SLS, Sierra Nevada, anybody that launches or lands out here, we support.
Thank you.
One quick one, I'm sorry.
One quick.
For landing, do you guys release these balloons for landing purposes as well?
Yes, we do. We release for any type of vehicle landing out here, whether it be SpaceX at LZ1 or something landing at the shuttle landing facility. We release balloons to support all of that.
How far would the landing variations differ with winds? Like, will it make a huge difference where the balloon is recovered?
No, the customer is more concerned with landing, about their thermodynamic profile and the density of the atmosphere for the vehicle landing. Winds, it depends if you're flying a vehicle in or if you're landing a first stage. So it's very dependent on what the customer utilizes.
Thank you.
Time to switch.
Can we get a video?